Today we're going to be looking at how we can solve triangle problems when the triangle is not a right triangle. We call these oblique triangles, and they could be your obtuse triangles or even your acute triangles. Now, one method we use to solve these is what we call the law of sines. Now, to determine if law of sines can be used, we have to go back to geometry, and we had different terminology for classifying triangles when we were comparing two triangles, and that's kind of the same terminology we're going to use. We had what was called side, angle, side. Remember, that was two sides and an angle in between them. We had angle, 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 side, side, angle. Don't switch that around. Side, side. Now, when we use law of sines, we're going to look for angle, angle, side. And quite simply what that means is if we're draw a triangle and we're given two angles and what we call a non-included side. In other words, the side is not in between them. We use what's called law of sines. Now, the law of sines is a very simple rule. It is a ratio. If we draw a triangle, we'll call it A, B, C. The side opposite A we call little a. The side opposite B we call little b. The side opposite C we call little c. The law of sine says if you look at the ratio of sine of angle A over A, that's going to equal to the ratio of sine of B over B, little b, which will also equal the sine of C over little c. This is what we call the law of sines. So let's take a look at some examples on how we can apply the following triangle information. A is 52 degrees, angle B is 31 degrees, and A is 8. So the first thing we have to do is, of course, draw our triangle, A, B, C. We know we're going to have a C there, so let's go ahead and draw it in. Opposite A is 52 degrees, and opposite A, they tell me it's 8. B is 31 degrees. Opposite I don't know, but we're going to call that little b. We don't know c, and we don't know little c. So we'll put that c out there too. Now the first thing we need to do is determine, one, is can we use law of sines? Well, if you notice, they gave me two angles and a side on the outside. So therefore, we can use law of sines. Next, I take a look at, what are we missing? I'm missing angle C, so I'm going to write out what I need to find. The first thing, I need angle C. I also need little b and little c. Box that in. Now, if I look here, which of those do you think would be the easiest to find? Of course, angle C. To get angle C, remember, all triangles have to add up to be 180 degrees. So to get angle C, I take that 180 degrees, I minus my other two angles, 31 and 52. And that's going to give us 97 degrees. So there's angle C, and I write it out, 97 degrees. Now, to get B and C, because it's not a right triangle, we're now going to have to use our law of sines. So we'll go ahead and do B first. Now, I'm going to set up my ratio. Okay, we're going to set up our ratio. So remember, it's going to be sine A over A, sine B over B, sine C over C. So I have to find out which one of those do I need. Well, I know A, and I know its opposite side. So I'm going to start off with something I know, set that equals to something I'm trying to find. Since I know A, I'm going to write that the sine of 52 over 8. Its opposite side is 8. And for B, I'm looking for B. I know its angle, so I take the sine of 31 over B. And I'm just going to solve this. Now, I'm going to use my calculator to kind of simplify a lot of these values here. Make sure you're in the right mode. You want to be in degree mode on your calculator. So if I solve this one, the first thing I'm going to do is I'm just going to go ahead and divide. Okay? So that's going to give me the sine of 52 divided by 8. And that gives me 0.0985, going about 4 decimal places, is equal to the sine of 31 over little b. Cross multiplying, I'm going to get b times 0.0985 equal to the sine of 31. Solve for b, just a little bit of division, okay? We take the sine of 31 and we divide it by the 0.0985. And I hit enter, and it gives me about 5.23. And there's B. To get C, little c that is, we do the same thing. And I'm going to do it down here, okay? So I know it kind of ran out of the room there. I take a look at what I know. I'm going to have to use the law of sines again. So for this time I know that's 5.23. I'm going to use my law of sines again. So I know A, so I take the sine of 52 over 8 equals the sine of 97 over little c. No sense reinventing the wheel. This becomes 0.0985 equal to sine 97 over c. So same idea. I'm going to get c times 0.0985 equals the sine of 97, and I can use my calculator on this problem right here. So we get the sine of 97, divide that by 0.0985, and we get enter, we get 10.08 for C. And there's our C value. All right. So let's take a look at number 2 here. Now we're going to start number 2 with you, and I would like you guys to finish this up, okay, because we got to talk about something else in just a little bit that's very big for us. Now for number 2, same idea. I'm going to draw my triangle. Here's A, here's B, here's C. A is 28, B is 31, little c is 8. Now, if you notice for this one, they gave me 2 angles, so they gave me an angle, a side, and an angle. That doesn't match my rule. I want angle, angle, side. We don't know this one just yet. Or do we? Of course, yeah. Oh, we can find angle C. If I find angle C, I can get that rule. I can get an angle, angle, and there's my opposite side. So we can use it even though it doesn't look like it from the beginning. So what we need to do then, see what we need to find. We need angle C, we need little b and little a. So to get angle C, I'll start down here. Very easy. It's 180 minus 31 minus 28. And if I type all of this in the calculator, ready? 180 minus 31 minus 28, we get 121 degrees. And now I can use my law of sines to get the rest. For example, if I want to find B, I'm going to use what I know. I don't know A this time, but I know B. So I'll go the sine of 121 over 8 equals the sine of 31 over little b. And if you're good at cross multiplying, you can actually kind of do this pretty quickly. So sometimes I tell students to just multiply here. B times the sine of 121 equals, and over here I might just use my calculator to do this one, okay? Makes it a little bit easier sometimes. You can take the sine 8 times the sine of 31. A lot of different ways you can do this. That becomes 4.1203. And if I divide by the sine of 121, just use the calculator, 121, close your parenthesis, we get 4.807. So there's B. And therefore to get C, or A, I'm sorry, do the same thing, use what I know, the sine of 121 over 8 equals, and over here to get A, I'm going to take the sine of 28 over A. And again, just cross multiply. A times the sine of 121 equals, and I cross multiply on the other side. This time I'm actually going to use my calculator. 8 times the sine of 28 is 3.756, and I divide by the sine of 121, and we get 4.382. And there's A. Now notice, I like my answers boxed in because it looks nice. These don't take that long to do. All right, now, you need to go ahead and make sure you look at part 2, because part 2 we talk about what's called the ambiguous case, and it's very much more challenging, okay? Thank you.